Okay guys, this is an example from the Copeland text, the second example 2.12, and this time instead of taking a single force acting on the shelf and working out what the force couple is at the wall, we're starting with a force couple at the wall, and you can see the force couple at the wall is clockwise 300 Newton meters with the force acting down of 240 newtons. So we're just going to look at how this type of problem is solved. It's really not that complex. In the first example, we had a force acting somewhere out on this shelf. So what we need to do is just the reverse of the previous problem. So what we're going to do is we're going to take this force that's acting down and we're going to move it, and we're going to move it out. So we need to take your 240 newtons and we're going to put it somewhere on the shelf. Now we need to know the magnitude and also the position. So we know that in our previous example that the force acting down at the wall was the same as the force acting down out on the shelf. So that makes our working out our force quite simple, really. So we know that if we were to do a free body diagram, what we would need to do is, we'll just draw it down here. It's just going to be, this is our F, we can call this F1. We move it out, we know it's 240 newtons, because that's what we've got here. We move another force out here, and we know that's going to be F2, which is 240 newtons. And we know that there's a reaction force that needs to stop this shelf from sliding down the wall. So that reaction force is going to be pushing up against this F1 force, and it's going to be, we're going to designate it as F3. Now it doesn't really matter what number you give your forces as long as you've got a way of telling what the difference between each of the forces is. So we know that that force is going to be 240 newtons. So we now know that we have, I'll just wait for the bell to stop. We now know that we've got this force F2 pushing down and this reaction force at the wall pushing up, which creates our couple, okay, which we know the value of because that's here, 300 Newton meters. So we take our formula, which is the moment of the couple is equal to force times distance. We know what our force is acting on the shelf, it's 240 newtons. We need to calculate the distance. So we can say that the moment of the couple, which we know is 300 Newton meters, is equal to our force 240 times d. And then we just have to solve, for d. So when we make d the subject of this formula, we say d is equal to 300, yes, it is equal to 300 divided by 240. I was just changing the subject of this equation here. And so we get a distance equals 1.25 meters. So step 3, you can just do a final diagram indicating that you understand what the force is and what the distance is. So we just draw our wall for our free body diagram, our shelf, our 240 newtons acting straight down, and our distance of 1.25 meters. And that is your answer. So that's just like the previous question or example, but just changing the way we do it. So the reverse, we're taking, instead of taking a single force and turning it into a force couple at the wall, we take a force couple and turn it into a single force. And that's how you do that type of question. Any questions, please come and see me.